All right, so let's get going here. All right, so for starters, well, you saw I put the solution up from the lab on Tuesday. Um, so actually, where did I write that? Um, Yeah, so we're going to be going off of our dictionary stuff today. So we're going to kind of transition from where dictionaries stop being handy to where objects start being handy. So we're going to start looking at object-oriented programming today. So what I'm going to do is let's give ourselves kind of an example. And it's something similar to, I think, what we've written before. But I'm going to modify a couple of things. So let's say that I want to have and everybody can see my screen right now?
Yeah.
Good. So let's say I want to create a function that generates for me a dictionary. And I kind of did this, I think, in the assignment, didn't I? I put one together here, but I want to. So it took in a radius, it figured out some stuff, and then it built a dictionary for me out of that stuff and returned it. So we're going to do something similar here where let's say we have a dictionary of a person that has a first name, a last name, and an age. I think it's something we've kind of done before. So I'm going to have a function here called build person dictionary. And this is going to take in a first name, a last name, and an age. And then what I'm going to do is I'm going to go ahead and build this dictionary. Remember, dictionaries are curly braces with a bunch of name value pairs in them. So I'm going to have first name is equal to my first name. Last name is equal to the last name that was passed in. And age is equal to the age. And then I'll go ahead and return that dictionary here. Okay, so I have now a function that I can pass three pieces of information to, a first name, a last name, and an age, and it will go ahead and build me a dictionary of those things and hand me the dictionary back. All right, so I can do something like print build person dictionary, Mike. Like that. And this function right here will take in those three parameters, Mike for first name, Littman for last name, 21 for age, and it will create a dictionary for me out of those and then return that dictionary. And I'll go ahead and print out whatever got returned, and we'll see that we have my first name, last name, and age in a dictionary. Okay, so we can kind of think of this as a constructor. This allows us to construct dictionaries that hold information about a first person, a last name, a person having a first name, a last name, and an age. Now, I can then write some additional functions that allow us to operate on those dictionaries. So I can say, get f name given person dictionary. And I can have this guy return dictionary at bucket f name. And that'll give me the first name from that guy. Similarly, I can write a function get last name given person dictionary and have this guy return the last name. I can say get age given person dictionary and have this guy extract the age. Go ahead. Oh, no question. Make sure nobody's in the waiting room or anything. Okay, we're good. All right, so now I have a single function that allows me to build a person dictionary, and then 3 other functions that allow me to kind of conveniently extract the pieces from it, so I don't have to remember the first name, the last name, the age, whatever. You know, we're kind of being like overly dramatic here with the number of functions for operating on these dictionaries because it's taking us down the path that we're going to talk about today. Okay, so we have our 3 functions here that just say, return the values from that dictionary. So I can go ahead and say, I'll store the dictionary that was built here inside of a variable. And then I can print out get fname from the dictionary. I can print out get lname from the dictionary. And print out get age. From the dictionary. Showing that those 3 things give me the individual pieces. Mike Littman, 21. So, and I can print out the dictionary beforehand if I want. So here's what the dictionary actually looks like. And then my 3 functions that extract individual pieces from the dictionary look like this. Now, none of this is hard, difficult syntax, I guess. Now let's kind of keep taking this down a path. What is it? Rand int, I think. Have we done random numbers in Python yet?
No.
I'm pretty sure the function is called rand int. Yeah, random between 2 values. So we'll just go ahead and I'll show you how to use this. So we're going to go ahead and create a whole bunch of people. So let me delete some of this here. So I'll go ahead and create a for I in range 1 to 100. So we'll go ahead and create a whole bunch of persons using our build person dictionary. And we're going to go ahead and store these dictionaries in a list. So we'll call this guy list of people. And we'll start this off as the empty list. There's nobody in our list of people yet. So we're going to create 100 people here. Actually, that'll create 99. Now this will create 100 people. All right. So what we're going to do is we're going to have the people have a first name. It'll be like fname 0, lname 0, fname 1, lname 1, fname 2, lname 2, very generic. But then we'll go ahead and use the rand int function to give us a random number that for the age. And let me just test something down here real quick. I think it's not actually built in.
Import random, I think.
Yeah, I'll have to import random, but I just wanted to see if it was in there. Okay. And if I say random.rand int 210. Oh, so I do need to just import it. So at the top, I'll import random. And then actually, before I do this here, let me just print a couple of random numbers. Rand int 210. And this is random, not random. Yeah, there's our random number. So I don't think we actually need to import random. Oh, we did. So we needed to import random and we need to say random dot. So we'll bring in the random library, and then to give ourselves a random number between 2 and 10. And I think it's 10 not inclusive. So for I in range 1 to 100, let's just print out a whole bunch of random numbers between 2 and 10. I think we'll get some 2s, but I don't think we'll get 10. I think the biggest number will be a 9. Oh, no, it does go up to 10. All right, so it is this value inclusive. So we'll go ahead and give ourselves ranges between, for age, let's say between 10 and 85. Let's do something like that. So we'll have 10 to 85. This will be for our age. We'll say F name is equal to F name, and then we're going to concatenate onto that the string version of I. So that'll be F name 0, F name 1, F name 2, so on and so forth. All right, then we'll go ahead and, well, we'll call this temp dictionary. This guy will be equal to build person dictionary, passing it F name, L name, and age. And I'll just go ahead and print out temp dictionary there. So we should see that we have 100 dictionaries that just get printed to the screen here with random ages and not so random first and last names. Rand int. Yeah, so we see randomness in the ages over there, and we have first name 10, last name 10, so on and so forth. Okay, so now we're using this function, build person dictionary, to go ahead and build a whole bunch of dictionaries given these 3 pieces of information. And we want to go ahead and store those inside of our list of people. So we'll say list of people dot append, and we'll add in our temp dictionary. And after this for loop is done, we'll print out list of people. So there's our giant list here. And see how it puts it in here. If I click that, it shows me the full contents of it. So there's my list of person dictionaries down there. Okay, so any questions about what we've done so far? All the little components of this. So we have a collection of stuff. What are we putting in there? We're putting in there dictionaries that we built using our build person dictionary function, which is built in terms of a random age and a first name and last name. So questions so far?
Did you do it with random letters in the alphabet?
There's probably a way to get random letters in the alphabet. At the very least, you can get the values for ASCII. So let me see, Python. Unicode. Let's see, char given Unicode. Has to be a little function kind of like int or something like that that allows us to convert a number to its char equivalent. Yeah, it looks like ord or CHR will give us the come down here. So if I say print ord of lowercase a, this should give me 97, which is the Unicode character for the lowercase a. And then I say lowercase b or z, it's 122. So if we say values between 97 and 122 here, for example, those are letters of the, these are the Unicode values for the lowercase alphabet. And then what I can do is I can convert each of those into a char, the character equivalent. So for instance, if I say print the character equivalent of 97, that should give me an A. Why is this off the screen down there?
It gave an A.
It did give an A?
Yeah.
I have an extra parenthesis on mine, apparently. There's my A. So the CHR function, kind of like string, kind of like int, it'll take a number and give you the equivalent character in the Unicode character set. So right now what I'm doing is I'm saying take 90, give me a random integer between 97 and 122, which is going to be the Unicode values for those guys, and then give me the character of that. So right now, if I print out age, we should see a whole bunch of, ages are like R, expand in shell, K, R, D, M. So it's giving me random letters now. So ord, O-R-D, gives me the ordinal version of a char. And CHR converts a number to its character equivalent on the Unicode lookup table. So there's the A. Right now, we'll keep our ages between 10 and 85, and we'll go ahead and fill this list up with a whole bunch of ages. Okay, so now we have a whole bunch of ages and first names and last names in a collection list of people. So now what we might want to do is we might want to say, well, what if we sum up all the ages? We're just looking for little utility things that we can do with our collection of dictionary representations of people. That's really how we're representing people right now, is through this idea of a dictionary. Okay. Yeah, just a reminder, I'd sent out the announcement and stuff, so I had contact with Senator Ron Johnson, so I have to wait for the results of my COVID test, which I think I'll get back tomorrow probably. So that's why we're not meeting in person, we're meeting only online until I have my results or whatever. Okay, so in any case, we now have this list of people. So what I'm going to do now is I'm going to write another function. And let's just say the purpose of this function is we want to take in a list of people stored in dictionaries, and we want to sum up all of their ages, something like that. So we'll say get sum of ages given collection of person dictionaries. I know it's a really long function name, but I just want to be explicit about what this guy does. So he'll take in a list of people as a parameter. And then what we want to do is we want to go through this entire list of people, getting the age of each of those people and adding it to a running total. So maybe we say sum is equal to 0. In fact, actually, why don't we take a minute now that these functions written, go ahead and take a minute and write this function that goes through my list of people and extracts the age from each of those people and adds them to a running total, and then in the end returns the sum. So take a couple minutes and go ahead and write that, so that in the end here I should be able to say print get sum of ages list of people, and it'll print out, you know, some number that is all of the people's ages, all those 100 people's ages added together. That's what it should ultimately do. So take a couple minutes and try to write that. All right, so let's take a look here. So we're going to create a variable because we want to remember our running total here. We want to go through every element in list of people. How many elements are in list of people? There are length number of elements. So I can write this a couple different ways. I can say for I in range 0 to the length of list of people. And then each time through, I can say sum is equal to sum plus get age given person dictionary. And which person dictionary do I want? I want list of people at bucket I. And then I can return the sum. So this loop takes I on a voyage between bucket 0 and the bucket of length list of people -1. Each time through, I'll use I to get me the dictionary that lives at that bucket in the list. Then I'll use my function, get age given person dictionary, to extract the age from it. Even though we can extract it directly, we wrote a function that does it, so we'll just use our function. So this will give us an age, and what are we going to do with that age? We'll add it to our current sum, storing the result back in our running total. When this loop is completely done, we'll return the current value of sum, which will come out here, our call to that function, and we'll print out the value. Why is it still, I'm not printing that anymore, am I? Oh, whatever. So 4,825 is our total age that came out of there. But if we run this multiple times, we would presumably get different values because it's going to give us a different set of random numbers each time. Okay. Now we might also, well, here, let me write this another way. So instead of this for loop, I'll just write this whole function a different time here. I'm talking about the for loop up here. So we'll have another version of this guy. We can use a for each loop to accomplish this. So we'll say get sum of ages given collection of person dictionaries 2. So instead of saying using a for loop to take I on an index voyage from bucket 0, bucket 1, bucket 2, so on and so forth, we can use a for each loop and say for a person in list of people. And then we can say we want to get the age given person dictionary of a person. So this for loop, a person will be equal to a different person. First time through, it'll be equal to bucket 0 of this, then bucket 1, then bucket 2, then bucket 3, so on and so forth. So rather than having access to the index where we are in there, we'll instead just have a variable called a person that we can use, and that is the next person dictionary that is stored inside of list of people. And I'll go ahead and call that second version of the function here. And we'll see that they both, oh, I forgot my semicolon, or colon rather. So we see they both give me the same answer. So logically, they're doing the identical thing. They're just using a little bit different loop to accomplish it. Now, similarly, we can say get the average. So what would we have to change here to have this function? I'll just grab it here. Get average age given collection of person dictionaries. So what would I modify inside of this function right here so that it returns the average age of the people in the list as opposed to the sum of ages?
Would it be like sum divided by a person?
So if we say sum divided by a person, what is a person? Tell me everything you can tell me about a person right there.
Yeah, you're right.
Well, no, let's go down the rabbit hole. What is a person?
It's a person in a list of people, or a variable within a list of people.
So it's going to be each of those individual people, right? So the first time through, it'll be the first person from here. Then the next time through, will be the second person, the third person, the fourth person. Actually, when we get to here, a person isn't even a variable because that variable lived and died. Its scope was
Okay.
this for loop. So it's not even a thing anymore. All right. So how do we calculate the average of something? What does average mean? If I give you 10 numbers and I tell you, give me the average of those 10 numbers, what do?
Divide by 10.
Yeah, add them all up and divide by 10, right? So if I
Right.
give you a collection of people called list of people, and we're already summing up all the ages, and I want to know what's the average age, what do I divide sum by? How many people are in list of people?
List of people?
Well, list of people is a list. How many people are in that list?
I don't know.
Well, if I give you a list that contains 10 people, the number of people in that list would be 10, right?
Correct.
I give you a list that contains 30 people. The number of people in that list would be 30. How do we
Well,
get
it's
the
100, isn't it? Or
well,
was it?
in this case, it happens to be 100, but all we know when we're looking at this right now is we have a list of people. How do I find out how many elements are in a list? The answer is on the screen right now, in some hidden somewhere in that code. How do I get the number of elements that are in a list? Any list. I can give you a list of numbers. I can say how many elements are in this list of numbers. How do I generically get the number of elements in a list?
Using the length function.
Using the length function. So I would divide this by the length of list of.
Oh, yeah, duh.
Okay, so I'll have my sum, I'll divide it by, this is the number of people in that list, number of elements in that list. We just happen to assume they're people because I named my variable list of people. All right, we always want to write things relative to, we always want to write things generically because this is a function that we can call multiple times with different inputs. So how many elements are in this list? It's going to be the length of that list, number of elements. Even though I happen to be calling it this time with 100 people, that doesn't necessarily mean I'll always call it with 100 people. So the number of elements in a list is the length of that list. All right, so now I have my sum divided by the length of that list, which should give me an average age. This will give it to me in floating point format. What can I do if I want to have it as integer division? What do I change here if if I have 5 divided by 2, instead of it giving me a 2.5, I want it to give me a 2.
For division.
Do that, right? Two slashes does integer division. So we can decide which makes more sense here. I don't know that there's necessarily a great reason to pick one over the other here. What we're doing is we're really looking for what is the average age in here. Now, since we picked a age between 10 and 85, what would we presume should be roughly the average age?
40.
So it looks like, mathematically about a 47.5. So you will take Actually, that's not right. We have 75 ages, right? So 85, let's just do this. 85 divided by 2 is 42. So add 10 to that, add 5 to that. We should have, yeah, it's still right, 47. We should get a 47.5 if we have perfect distribution of random values. Now, I think we're going to find that we don't quite have perfect distribution of random values. So I'll go ahead and I'll print out get average, and this is going to be my list of people. 47.35, not bad. 48.67. 44.26. All right, so we're getting roughly, you know, the right kind of average. Now, this is more of a trivia piece of information, but something that's interesting with, I guess, random number generators is, you know, we can see here that, hey, having a random number generator is kind of a handy thing. We can do different things with random number generation. But true sources of randomness are actually hard to come by. And we can apply this to things like video games and stuff like that, as well as, you know, if you go way back to, you know, Nintendo days, you look at, you know, Super Mario Brothers or something like that, the things on the screen were not all that random. You could pretty much bank on timing of things and stuff like that because of how those games were written, where, you know, when the level first started, one of the little turtle dudes spawned and he just started walking, and he walked at a constant rate. So, you know, on a given second, you knew where he was going to be on the screen. Well, you look at modern day video games with like artificial intelligence and things like that, where, you know, the non-player characters in these games are, you know, trying to walk around the world as if there's a human being controlling them, something like that. And, you know, they should get better and better and better at being somewhat random in their movements, but there's still patterns that we notice. You know, so finding true sources of randomness, even with it just becoming an equally distributed list of values, is a tough thing. You could have an entire math course on sources of randomness. It's actually kind of a fascinating thing. And even if you go outside of math, so we'll throw a little Christian worldview into this, it's still difficult to find true sources of randomness. You start going out into you know, the real world, and you say, oh, well, maybe I'll you know, look at the number of cells in a leaf or something like that. You know, I'm just picking random stuff. You start seeing that there's even patterns in that, things like the Fibonacci sequence and that kind of stuff is found all throughout nature. So even going out and looking at things that feel somewhat random, it's still hard to find randomness. Years ago, you know, when you were like encrypting hard drives or something like that, one of the things that they would do to, you know, try to add some level of randomness is you can move your mouse around, and that was just creating, you know, point data that it used to encrypt the hard drive, for example. So the idea would be, as you moved your mouse around, you would, you know, the trackball this is before the little laser mice, but, you know, it would move in all sorts of different positions, and you would get, you know, a bunch of data that was hopefully somewhat random. Well, then they did some research on that, and they found that even that wasn't necessarily overly random, you know, because if you tell a person and they have, you know, to move a mouse around for 20 seconds or something like that, really, what are they doing? They're moving it around inside this little area. And a human being, when they move stuff, they have a pattern of their movement and that kind of stuff. So the data wasn't as random as you might assume it is. So this is more of just kind of an interesting truth about randomness, is that if you truly need very, very random data, which in this case we don't, you know, we just want a kind of a distribution of ages that are random-ish, and we're okay with that. But if we need a true set of randomness, that can sometimes be hard to come by. And is just kind of an interesting thing. Something that Linux has is they have a device called Random, which is just a file that just collects junk from your operating system running. That you can hit that random file and pull just some bytes out of it. That'll give you a number. And the hope is that since that was created from you randomly using the computer and excess memory just getting stored there, stuff like that, that it gives you somewhat of a reasonable source of randomness, is the idea. So kind of a an interesting little spin on things there. Okay. So any questions about the code we've written so far? Makes reasonable sense, kind of what we're doing. We did some mathy stuff, built some dictionaries, built some functions for helping us operate on those dictionaries, but before too long, these things are going to it starts feeling very disconnected, right? We've kind of stored in our mind this idea that, oh, I'm going to keep track of 3 pieces of information about a person in a dictionary just because. And even though dictionaries allow me to, have collections or have labels for my thing, so I can label it as the first name or the last name or the age, that's better than saying, well, I have a list and bucket 0 of the list is going to be the first name and bucket 1 of the list is going to be the last name and bucket 2 of the list will be the age. We could say it's better than that. It still feels like we have our idea of a dictionary in one place, and then we have all of these extra tools kind of laying around that allow us to operate on it. All right. So now typically when you're, if you're buying a bunch of tools from Home Depot, you also want to get some kind of toolbox, right? That you can throw those tools into and have them organized in some sort of way. So maybe you have a toolbox that has all your screwdrivers in it or something like that. So that when you need a specific screwdriver, that screwdriver can be found in your box of screwdrivers, something like that. So we have this idea of organizing our data in interesting ways. So what we're going to introduce today is the idea of a class, objects. And remember back in Unit 1 when we were talking about kind of the history of languages, and we mentioned that we had the difference between the procedural telephone and the object-oriented telephone. And we said that the procedural telephone looked kind of like this giant pile of wires that, oh yeah, when you look at it, you say, okay, well, that's a pile of wires. I say it's a telephone. You don't really believe me because it doesn't look like a telephone. But after you've investigated it some, you finally come to the conclusion that, oh yeah, that is a telephone. Okay, it just didn't look like one. The object-oriented version of a telephone, somebody can hold up a smartphone or anything that's a telephone. You can say, oh yeah, I can identify that. That looks like a telephone. And that has meaning to it. Telephones have certain features that you expect them to have. And I know smartphones have a zillion different things, but if we just think about this, kind of from a simple perspective, a telephone allows us to make a phone call, speak into the phone, and hear the other person on the other side. Keep it simple, right? So there's some public interfaces of a telephone that we expect all telephones to have. We know that telephones are kind of maybe built in some different ways depending on how fancy the telephone is. But all those wires and stuff we know are there, but they're kind of hidden inside of the package. Okay. What we've written here so far, in our stupid little example today, we have a lot of these wires kind of exposed, right? And, when we write our objects, you're going to kind of see it in a similar way, but I want you to think about these as kind of each being a screwdriver. I have, my analogy of a toolbox filled with screwdrivers. I don't have my toolbox here. I just have screwdrivers laying all over the place, and that's not the right way of doing things. It happens to be the way a lot of us do things in real life, which is kind of ironic, given that the idea of object-oriented programming is it allows us to represent things in the way that we solve problems in real life. But maybe we can extend that a little bit and say it allows us to solve problems in the way that we really should solve them in real life, because at least at my house, my tools are just all over the place. And, I'm always looking for that one screwdriver. And then when I find it, I never put it back, and then I can never find it again, or I find it when I don't need it. something like that. So we can say that good programming practice, good tool maintenance would be to store all your stuff in a nice organized way. So we're going to introduce the idea of a class. So we have a class data type, which allows us to encapsulate this stuff inside of a new type of organization called a class. Now, classes contain three things. They contain fields. Fields are like our name value pairs, kind of like what's the contents of a dictionary. Okay, these are the variables that belong to a class. Then we have constructors. These are the things that let us build an instance of the class. And we've kind of, so if I want to look at here, this is kind of our version of our constructor for our representation of persons here before we have access to classes. Since I haven't introduced classes yet, we're saying I've decided I'm going to store my persons in dictionaries. And the way I can easily construct one of those dictionaries is give me 3 pieces of information. I will build the dictionary for you and return it. That's what this guy does. So we can call him kind of a constructor. But as far as classes are concerned, constructors are embedded within the class. All right. And then we have things that are methods, things that operate on the fields that are part of the class. All right, so we can think of this as like kind of our object-oriented version of a telephone where we know there's a whole bunch of stuff inside of that phone. And if we manipulate the phone in the right way, we get access to those features. But they're still all completely encased inside of the telephone object. So if I want to take all the features of a telephone with me, I could just throw it in my pocket and walk off. That doesn't mean I have to use every one of those features, but they're all nice and conveniently packaged for me. So it's easy to take them from, from my house to my car, or whatever. Your code is portable if we're kind of thinking about this in computer programming guys. All right, so what I'm going to do here is up top, I'm going to create a class. So we're going to create a class called person. All right. And our class person is going to have, how are we on time here? Oh, we're good. Our class person is going to have some fields. I mentioned there's 3 different parts to a class. We have fields, we have constructors, and we have methods. Early on, we'll probably just have one constructor. Now in Python, and we've kind of seen this syntax before, remember down here, this underscore thingy, which is just kind of how Python represents their kind of specialized built into the language functions. So in Python, constructors are always called, we're going to have define underscore init underscore. This is our constructor. We are initializing an object. Now, the first parameter here will always be self, and we'll talk about that here in a minute, but let's just kind of get a piece out. So for right now, we're just going to write self in there. And then we're going to say that for a person to work, we're going to need a first name, a last name, and an age. Those are the pieces of information that are required to build a person. All right. And then what I'll do is I'll say self.fname is equal to fname. Self.lname is equal to lname. Self.age is equal to age. And I'm actually just going to leave it like that for a second. So that's going to be my entire class for right now. It doesn't know how to do anything else. And I'm going to come down here and I'm going to go ahead and I'm going to create P is a person, Mike Littman 21. So I have invented my own variable type that's of type object. So I'm going to create a person. And so this code right here, this will call the init function, that constructor of person. The constructor for person takes 3 parameters. First name, last name, and age. Don't worry about the stuff part yet. Ooh, somebody got a question? All right, so it takes in 3 parameters. Again, don't worry about self for the moment. So I went ahead and I built a person, which Python knows to call that underscore underscore init underscore underscore function. And I'm passing in Mike for the first parameter, Litton for the second, 21 for the third. Now I have a person. So now I can say print p dot f name, print p dot l name, print p dot age. And we see we get our first name, last name, and age. So I'm able to now create this new type of object that has this collection of pieces of information in it, and then I can extract those pieces of information. Now, next time we're going to talk about public-private variables, but right now we're not going to mess with that. So we're just going to keep it simple where I can create fields like this and I can directly access those fields, no harm, no foul. All right. So as of right now, we might say, well, this really isn't any better than our dictionary representation, right? You know, if we look at this, you know, is this really better than saying we have a dictionary that has a first name associated with the first name value, a last name associated with the last name value, an age associated with an age value? I'm not sure it's really any better. Maybe it seems a little different and it doesn't seem...
Cooler? Just kidding.
Go ahead.
I was saying it seems maybe a little bit cooler. That's about it.
Yeah, but I promise you it is better because we're going to see it has some extra abilities. But, you know, we're not necessarily, you know, impressed yet. Just one more way of doing kind of the same thing we just did 5 minutes ago. All right, but this builds us one of these guys. Now, I can do something like def display. Let's say I want to have a function that lives inside of a person, and this function will kind of display a person in some sort of like pretty format, something like that. All right, so this display function, it's not going to need any parameters. I still need to put self there, and I'll talk about self in a minute again. It's incredibly important, but it's also a little bit confusing, and it's not overly important to us yet, even though we seem like we're using it a lot. All right, so I'm going to have a function called display. Notice this lives inside of the class person. And what I'll have this guy do is we'll just go ahead and we will print, and I'm going to print out an F string. And this F string will have the first name, the last name, and then maybe I have open parentheses and the age. So this will be self.fname, self.lname, self.age. Now I'll show you this and then we'll come back here and we'll use this to explain our self. All right, so we're doing this as a formatted string. So when a person displays themselves, it's just going to kind of put their fields together in an interesting way that makes it a little cleaner to display. Because right now I'm displaying each individual part here when I could just say p dot display like that. I could just say p display yourself. And there is the display version of my person. Now that's something a dictionary can't do, right? I can't create a dictionary and then have it also perform extra tasks. What did I have to do to accomplish that today? Well, I had to write all these extra functions that did, and these were just kind of laying all over the place, like that analogy of having all your screwdrivers laying all around the house, that type of thing. All right, now let's give some definition to this self keyword here. I'll just put it in a slide right here. Self. Self is how an object refers to itself from within itself. And we can see the real life example of this in and of ourselves. So remember, the whole purpose of a programming language is to allow us to solve problems, tell a computer what to do but a modern programming language hopefully allows us to do that in a way that's similar to the way human beings already solve problems. So with that in mind, whenever you're talking about yourself, you don't refer to your, I mean, well, some people do, but you don't refer to yourself by your first name. Like, I don't walk up to people and say, you know, well, Mike is 6'5", you know, or, you know, Mike is going to the grocery store. We say, I am going to the grocery store. Okay, or you know, something like that. We, you know, we have references that when we're talking about ourselves, we don't say our name. We instead have a special vocabulary for referring to ourself. Okay, so the self keyword is just that. If I'm looking at it out here, out in my main program here, the way I know about this object is through something called P. That's its name. Okay, you know, if I want to really hit home with my example that I have right now, I could say that this is Mike, and I could say Mike.display out here. But now if I'm inside of my person object here, let's say I'm inside of display, I don't have a variable in here named Mike. That variable is out there in my main method. That's where its scope is. Inside of person here, if I want to talk about my own stuff, I refer to myself as self. Hence the reason they called it self, because you're talking about myself. Keep in mind, you can have multiple instances of person. We can have a person for Joe Smith and a, you know, 500 other person objects. And each one of them, when they talk about their age or their first name or their last name, they're going to be talking about pieces of information that's unique to themselves, not necessarily pieces of information that are part of the global scope. So when we are inside of the implementation of a class, and we want to refer to things that we own or something that belongs to us, we use this keyword self to talk about our own stuff. Okay, now notice that this self keyword is passed around inside of Python. This is how Python has implemented their version of object-oriented programming. So when you take the CSC470 class where we write programming languages, we go and write an object-oriented language, we're going to be talking about this. How do we accomplish the idea with an interpreted language of objects? Where does self come from? So with Python, they're passing self around, so we always have access to that variable. When I say self.fname, all variables resolve to their most local definition, and the most local definition of self here is its binding right there, which came from somewhere. Because when we initialized a person here, we scroll down and I see where I built my person. Notice that we're not passing anything in here for self. Somehow that's magically occurring. Okay, it's part of the syntax to make objects work in Python. It's how they had to rig it to make it function, because object orientedness was something added on to Python. You know, it was built as an interpreted language that had some features, and then as they evolved the language to have more and more features, they had to either reinvent past versions of the language and say, oh, well, now our syntax is going to be broken, like you did that paper on Python 2.7 versus Python 3, where there's some inconsistencies with those languages where they had to say, look, these things need to change, or, you know, it's time that we have a refresh of the syntax and not necessarily worry about breaking old versions of the code. But at the same time, the way objects were handled was maybe something, since objects go pretty deep into the language. It's a major part of all modern programming languages. So you start changing one thing about an object, now you might break, you know, large swaths of the language, and you have to go back and bug fix those things because you changed a little bit of something with the syntax. So in any case, when we build a person, we pass the 3 parameters, even though the syntax for it expects this magical one, which is how this object refers to itself from within itself, but it handles it for us. We didn't pass that information. We just passed these 3 things. Okay, so the self keyword is how an object refers to itself from within itself. A very, very, very important concept that's going to take a little bit of getting used to, but hopefully I kind of I prefer the verbiage in Python where it's called self, because that kind of, it's how I talk about myself. That kind of makes some sense. If we think of ourselves as being an object, when we're referring to ourself inside of our head, we might talk about, I'm going to do something, or it's mine, it's myself, whatever it is. Those are the ways we think about it. We don't say our first name, for example. In other modern languages, they use some alternatives that mean the same thing. Some use self. But for example, Java and C# and C++ all use this as the way that an object refers to itself from within itself. This particular object, this instance of a person. Okay, so that's what they use. Now, an interesting language that I have always seen this with this one language, and it's not very popular anymore, but for a long time it was really popular among kind of non-programmers that wanted to put together business applications, is how many of you have heard of a language called Visual Basic? Anybody ever written anything in Visual Basic before? Can't tell if anybody said anything. Well, whatever. In Visual Basic, uses me as the way an object refers to itself. If I'm talking about myself, I'm talking about me. So that's so hopefully between the different uses of these things, you're kind of getting an idea of how this word works. When I'm inside of an object, I'm implementing that object, I have to have some mechanism for talking about myself. Myself being the object I'm in the middle of building or in the middle of writing logic related to. Okay, so we have a way of displaying this guy. Now we'll also, I'm going to go ahead and write another class. I'm going to create a class called person collection. And a person collection is going to kind of do the thing that our list of persons did before, where we're going to have a collection of persons to work with here. So we're going to go ahead and define __init. And initially, when we build a person collection, it'll be an empty collection. So self dot, we'll call this parameter the people, will start off as an empty list. There's nothing in there yet. All right, but now we'll also go ahead and we're going to create a function to add a person to my collection. So I'll say def add person, taking self and a person. And we'll say self dot the people dot append a person. Okay, so that's going to be every single time I add a person to my person collection, I'll call add person. I will pass them an instance of the person class, and it'll go ahead and append that person to my internal collection. Now, keep in mind that when we go and use this tool, our person collection, we don't have to know how this was implemented. When you use your smartphone, you don't have to know how various features inside your smartphone were actually written. You just have to know how they work so you can properly use the tool. All right, so if I come down here, and I'm going to go ahead and get rid of this line. And what I'm going to do is up here, I'll kind of solve both problems at the same time. So I'm going to say I'm going to create a collection of people is going to be equal to a person collection. So that'll give me an empty person collection. And then this was the way I did it before using dictionaries and stuff like that. What I'll do here is I'll go ahead and say collection of people dot add, what I call it, add person dot add person. And the person I'm going to add is a new person built using fname, lname, and age. That's what I'm adding to that collection of people. So I'm doing the same logic 2 different ways right now. I'm going ahead and I'm grabbing my 3 parameters here that I'm randomly generating or whatever. And then in this case, I'm using my function to build a person dictionary, and then I'm appending it to my list of people. Whereas in this case, and actually if you want to keep it separate just so you can kind of see how these guys, this isn't necessarily shorter, I'll say P is equal to, actually, let's say a person. Actually, it's called temp person is equal to that person. And then we'll say add person, temp person. So this code right here builds a dictionary using our build person dictionary tool, and then it appends that directly to the list. So in this case, we know we're working with a list, and we know that we have a local function that's building this dictionary for us. Down here, we don't know how this is implemented. We just know that, oh, we have an object type that I can pass 3 pieces of information to, and it gives me a person. Similarly, I have a collection of people that I built up here, as opposed to just a list. Even though we know that under the hood, our person collection maintains a list for us, it doesn't have to do it as a list. It could do it whatever way it wants to do it. It's abstracted from us because all we need to think about is, oh, I need to have a collection of people. So I'll go ahead and create a collection of people, and I'll add people to that collection, even though we know the code behind is very similar. Okay. Now I'll go ahead and also teach my collection of persons to display itself. So I'll say display. And what we do to display ourselves is we go through and ask each of our people to display themselves, because a person knows how to display themselves as well. We wrote that a few minutes ago. So our display method for person will be for a person in self.thepeople, a person.display. Because a person knows how to display themselves. This for loop will take a person on a voyage through my collection of people, which is up here a list. So now when I go ahead and ask a collection of people to display themselves, it'll give me my extra parenthesis there. It'll give me my big list of people. All right, so this will display that collection of people. So we've abstracted that logic inside of this object that lives up here. And now in our main, the idea is that our main method then gets pretty small because it only has kind of the highlighted features. All right, questions about any of that? So our homework is to create a dice class that represents, well, let's say that keeps track of a number of sides for a single dice object. For example, a 6-sided die would have 6 sides. So a lot of times this is called a D6. A D20 sided die would have 20 sides, etc. A dice object should be able, should provide a roll method that, when rolled, generates a random number between 1 and the number of sides. So for example, if I had D6 is equal to dice 6, for example, and then I said D6 dot roll, this should give me a value like 1 or 2 or 4 or 6, something like that. Every time I roll the dice, so maybe I get a 1 the first time. If I then roll it again, maybe I get a 5, so on and so forth. Similarly, if I create a D20 with a 20-sided die, and then I say D20 dot roll, I might get a 15. I might get a 2, stuff like that. You must use the random int function to generate random rolls. Okay, so we're effectively having the ability to, in software, build ourselves a dice that we can then roll. All right, does it make sense what I'm asking you to do? Let me fix this here. All right, so I gave you some examples here. So for right now, you could just create single dice. You can create a bunch of them if you want, and then tell each one to roll. Next time, we'll be putting those guys together. Now, because next Thursday is fall break, we'll go ahead and we'll do our midterm exam the Tuesday following break. So on Tuesday, we'll spend a little time talking about the exam and what to expect and things like that. Do remember that the way my exams work is if you do poorly on the midterm and you do better on the final, I'll replace whatever you scored on the midterm exam with whatever you get on the final. So you can potentially get a 0 on the midterm, come in and ace the final, and have 100% for the midterm and the final. All right, so hopefully the midterm kind of tells you whether or not you're getting as much out of the assignments and stuff as you should be getting out of them. Now, as of right now, let's plan on still being online on Tuesday. I should have my test results back, I would think tomorrow maybe. So if I test negative, which is what I expect I will, then we can be back in person on Tuesday if you would like. But as of right now, since I don't know, let's plan on online on Tuesday. All right, questions, comments, concerns, bribes. And I will post the code that we worked on today up on Slack as soon as we're done here. So you'll have my sample code from class. All right, I will see everybody on Tuesday. Question.